Hello everyone, and welcome to Calculus. Today we're going to be studying definite integrals. So there's really just one extra step to a definite integral versus an indefinite integral. So just for a minute, we're going to ignore that 0 and that pi. Just pretend they weren't there, and this is a very straightforward function. We can even move the 8 to the outside if you'd like. It's a constant, but it still will be in our answer. And the integral of sine is negative cosine. Now be careful that you don't write the negative there. It would look like 8 minus cosine. Let me put the negative out front. If this were an indefinite integral, you would add a plus c and you would be done. But instead, it's a definite integral. So instead of adding plus c, I'm going to add a bar to the other end. So I'm on this step right here. I've found the antiderivative. And I'm going to add a bar, and I'm going to rewrite these two numbers, 0 and pi. And now I'm going to plug pi in first, so it's going to go from the top to the bottom. So b minus a into my antiderivative. Negative 8 cosine of pi minus negative 8 cosine of 0. Cosine of pi is negative 1, so this becomes positive 8. Cosine of 0 is 1, so this piece becomes negative 8, but then the negative negative would make it plus 8 for an answer of 16. So with definite integrals, because the work is mostly just practicing your integration, but then adding this step, there are some of you that really don't need to watch this video. So I have recorded all the answers. We just did number 1, but you can take a screenshot of this. You may want to come back to the video when we get to the second section and watch at least the first one, possibly even all 5. But for 1 through 10, if you can get these answers on your own, then you can just skip right over this video. Okay, number 2. So when people see a problem like number 2, they immediately think they're going to do u substitution. U is equal to x squared plus 1. Du is equal to 2x dx. But while you are allowed to add a 2 and a 1/2 to the problem to make your 2 dx, you are not allowed to add an x. So that's how you know that that is not the correct way to do that problem. You can never add a variable to the problem. Do you remember how to do it? You're going to have to expand. So I'm going to rewrite it. X squared plus 1 times x squared plus 1 is going to give me x to the 4th plus 2x squared plus 1. And now I can integrate. X to the 5th over 5 plus 2x cubed over 3 plus x over 1. And again, I would normally write plus c and call it a day, but instead I'm going to write it from negative 2 to 1. So the reason I say this, we pronounce this the integral from negative 2 to 1. So we say the negative 2 first because they're always going to go in number line order. But when you actually plug them in, you're going to plug in a 1. So I'm going to do it down here. It's going to be 1/5 plus 2/3. I'm plugging in a 1 plus 1 minus, and now you plug in the negative 2. Negative 32/5. When I plug in a negative 2, I get negative 8 times 2 is negative 16/3 minus 2. Might be easier to go like that. I'm not sure. So you might want to go through and add all your thirds with your fifths and your numbers with your numbers. So this becomes plus 32/5. This minus and this minus become plus 16/3, and this minus become plus 2. So now I have 33/5 plus 18/3 plus 3, which this piece is going to be 6 3/5 plus 6 plus 3, which is going to give me 15 3/5, or 15.6, or 78/5. Lots of ways to write the answer. Okay, that's number 2. Again, you can stop anytime and just do these on your own, but this is a great way to just get some integral practice again. I'm hoping that the first thing that you do is you change this to 3 minus 6x to the negative 2. That's the easiest way to handle that integral. So now the integral is 3x to the first over 1 minus 6x. I'm adding 1, and then I'm dividing by negative 1. So I get 3x plus 6 over x. I put my bar instead of a plus c, and I'm going to plug them in. When I plug in a 2, I get 6 plus 3. Always plug in the top one first, and then put a minus in between them. And then when I plug in a 1, I get 3 plus 6. And that comes out to be 0. 9 minus 9 is 0. So the purpose of number 4 is to remind you that this is an integral, or a formula that you need to have memorized. Sine squared theta is equal to 1/2 minus 1/2 cosine of 2 theta. Okay, so I'm going to rewrite this as the integral from 0 to pi. If you want, you could take out the 1/2 and just do 1 minus cosine of 2 theta. That might be an easy way to do it, d theta. I am going to let my u be, sorry, that wasn't working for some reason. My u be 2 theta, which means my du is equal to 2d theta. I don't have a 2d theta, so I am going to put in a 2 and another 1/2. So this 1/2 didn't help me. I need another 1/2 to account for that 2. So I can rewrite this as 1/4. Now this is going to sound really funny, but once you switch it to u, you actually can't write in the 0 to pi anymore. It no longer, like, these are only for theta, but now I'm doing my problem in terms of u, so don't rewrite those because they would be incorrect. And we'll talk more about that later in this video. 1 minus cosine of u, and I do have my du. So now I can actually do the integral. The 1/4 is a constant, so it's going to stay right there. The integral of 1 with respect to u, this is the biggest place that people go wrong. The integral of 1 du is not x, it's u. That is the number 1 error. You've been warned. And then the derivative of, not derivative, the integral of cosine is sine. And if you're trying to remember if it's positive or negative, I personally just always do it backwards. So the derivative of sine is cosine. It stays positive or stays negative, so that is correct. And then before I actually finish, I change it back to u. Change it back to x, so I change the u back. And I get 1/4, remember u is 2 theta, minus sine of 2 theta. And now that it's back in terms of theta, I can put my answers back in, which is 0 to pi. And I'm going to plug those in. 1/4 of 2 pi minus sine of 2 pi minus 1/4 of 2 times 0 minus sine of 2 times 0. This piece becomes 1/4 of 2 pi is pi halves, and sine of 2 pi is 0, so that's just going to go away. And then 2 times 0 is 0, and sine of 0 is 0. So that was actually the only piece that had to be done. And the answer is pi halves. So this one, honestly, we're on a worksheet called definite integrals, but this is really just practicing your integration skills, and knowing this formula was a key part of that. Okay, nice basic one, little breather here. So the integral is just straight up. The integral of sine is negative cosine. And how do I do that personally? I think to myself, the derivative of cosine is negative sine, so this must be a negative. Put my little bar on there. If you're in AP, you are going to have these memorized. If you are in honors, I hope that you've expanded your table enough to have all these things recorded. But cosine of all the halves, cosine at every single half, 1/2, 3 pi halves, 5 pi halves, 7, all the halves is always 0. And cosine of 0 is 1. Cosine starts at 1. I mean, it goes in the other direction too, but at 0, cosine is 1. So the answer is 1. Number 6. For me, the first step would always be to get rid of a square root. There's really no reason for square roots in calculus. We always need to switch it to a fractional exponent. I am going to use u substitution. U is 1 minus x squared. And I see that when I do that, I get negative 2x dx. I don't quite have that. I have the x dx, but I don't have the negative 2. So I'm going to add a negative 2, and to compensate for it, I'm going to add a negative 1/2 to my problem. Now I can rewrite this. That negative 1/2 has to stay. Remember, do not put the negative 1 and the 0 on there. It will be wrong at this point. And then all of this, the x, the negative 2, and the dx are all my du. And this piece is just u to the 1/2. Now I've made it a nice, easy integral to do. Negative 1/2 is a constant. The integral of u to the 1/2 is u to the, add 1, 3/2 divided by 3/2. But dividing by 3/2 is hard. So instead, let's cancel that out. Let's flip and multiply. Or you might call it keep change flip. Now my 2's cancel, and I get negative 1/3 u to the 3/2. So I am going to rewrite that back with the u's substituted correctly back in. So 1 minus x squared to the 3/2. And instead of plus c, so I would normally be done, but because this is a definite integral, I have to keep going. Remember to start with the top one. So I plug in the 0, negative 1/3 times 1 minus 0 squared to the 3/2 minus, I'm going to do the whole second one, plugging in a negative 1. Negative 1/3, 1 minus negative 1 squared to the 3/2. It looks awful. It's not going to be that bad. 1 minus 0 is 1, and 1 to the anything is still 1. So this entire awful looking thing is just negative 1/3. And then this, negative 1 squared is positive 1. So 1 minus 1 is 0. 0 to the 3/2 is still 0. And 0 times negative 1/3 is still 0. So minus 0. So my answer is just negative 1/3. Just saying it again, this worksheet is less about definite integrals and much more about practicing your trig integration, or just your integration in general. In this case, your trig integration. So whenever you see two trig functions, let one of them be u, and hopefully the other one will be du, and that'll work out. To choose which one is u, I choose the one that's having something complicated done to it. It doesn't mean you should put cosine squared 2x here. No. Okay, you don't want to actually put the whole complicated thing. You just want to put the cosine of 2x. That way you can rewrite this as u squared, which is not a complicated integral to do. So the derivative of cosine of 2x is negative sine of 2x. You always should know the formula, and then times the derivative of the inside, which is 2. I do have the sine of 2x and I do have the dx, but I don't have the negative and I don't have the 2. So I'm going to multiply by a negative 2 and a negative 1/2 to keep them equalized. So I didn't really leave myself enough room, sorry. So I'm going to put my negative 1/2 out there. All of this is my du, and this is u squared. It's easiest to do an integral when it's in the numerators. Not easiest, I think it's the only way. So the negative 1/2 is a constant. I raise the power by 1, and then I divide by whatever I get. This gives me, notice I switched it to you. I did not keep writing my limits of integration. You don't want them there because they're different. The negative and the negative make a positive. The 2's on the bottom, and this u to the negative 1 I can move to the bottom and make it positive. And now I'm going to put my u back. U was cosine of 2x. Now that I've returned it to x's, I am going to put my 0 in my pi 6, but I'm going to put it on this side because I've already finished the integral. Once you've finished the integral, you can go ahead and make your bar. And now I'm going to plug it in. So again, a lot of review here. How do we handle this? Well, when you have cosine of 2 times pi 6, it's not cosine of pi 6 and then times 2. It's literally cosine of 2 times pi 6. So this is cosine of pi thirds. And then cosine of pi thirds is 1/2, which is awesome because then this is just 1. And on this side, it's going to be cosine of 2 times 0. So you do the 2 times 0 first. And it's just cosine of 0, which is 1. So since this little piece is 1, we end up with 1 over 1 minus 1 over 2, which is 1/2. Okay. Number 8. I'm going to switch this to a 1/2 power, and I'm going to let my u be 4x plus 1. My du is 4 dx. I don't have a 4 dx, so I'm going to put a 4 into the problem and put a 1/4 on the outside to counterbalance it. The 1/4 is a constant. The integral, I drop the 0 and the 2 since I've switched to u, and those are representing x values, not u values. And now I have u to the 1/2. And this whole piece right here is equal to du. So I can write du. Now that it's in terms of u, I keep the 1/4, which is a constant. I raise the power 1/2 plus 1. So 1/2 plus 1, you can do 1/2 plus 2/2, which would give you 3/2 to the 3/2 divided by 3/2, which is awful. So I'm going to keep the top, but I'm going to change it from division to multiplication and flip this. Keep, change, flip. And that gives me the 2 and that 4 cancel, reduced to 1/2. So I get u to the 3/2 over 6. Or you could write it as 1/6 u to the 3/2. I am going to put it back now as x's. So it's 4x plus 1 to the 3/2. And now that it's in x's, I can go ahead and fill in a 0 and a 2. So first I'm going to put in the 2. 8 plus 1 is 9 to the 3/2. And then subtract, I'm going to put in the 0. 0 plus 1 is 1 to the 3/2. Remember that something that's to the 3/2 is the same as square root of that something cubed. This bottom number is the fractional exponent, which represents the root. So this is the square root of 9 and then cubed. So it's 3 cubed, which is 27. So I have 27 over 6 minus the 1 to the 3/2 is just 1 to the anything is still 1, minus 1/6, which is 26 over 6, which can be reduced to 13 over 3, or you might write it as 4 1/3. Number 9. There's no reason for any u substitution. This is a straight up integral. I can never remember if it's positive or negative. So I just know that it's going to be sine, either positive or negative, and then I do the derivative. So the derivative of sine is cosine, so I don't need any negatives. And I'm done. I could write plus c if it didn't have the 0 and the pi, but I do need to use them. And that gives me sine of pi. Always do the top one first, minus plugging in the bottom one, which of course is 0 minus 0. So you're done. All right, last practice problem. So there's two choices for how to do this. You might choose to expand it and make it 16 minus 8w plus w squared, and then do the integral. Or you can do u substitution, 4 minus w, but you will have to be careful. Your dw or your du is going to be negative dw. So you would have to add a negative to the problem. It doesn't really matter to me, but I'm going to do it this way because we don't normally do one without u substitution. So this becomes 16w minus 4w squared plus w cubed over 3. I didn't need u substitution, so I can jump straight into writing these. I plug in a 0 first, and I get 16 times 0 minus 4 times 0, which is just 0, and 0 cubed over 3. It's all 0. So it's 0 minus, and now I'm going to plug in the negative 2. That gives me negative 32. Now be careful, exponents come first. So it's not negative 4 times negative 2 and then squared. It's negative 2 squared, which is 4, times negative 4 is negative 16. And then negative 2 cubed is negative 8 over 3. So because they're all negative, I'm just going to put them together. This is the same as 2 2/3. So 48, 50, it's minus a negative 50 2/3. So it becomes positive 50 2/3. So hopefully these integrals are feeling like something that you can do. If not, I hope that was a little good extra practice for you. But definite integrals is really just an extra step. So I want to introduce something new called changing the limits of integration. This is not required after you do these 5 problems. Some people love it. Some people don't use it at all. If you're in AP, you must understand it. They will put this on the exam. But if you're in honors, do these 5 problems. And if you never do this again, it really won't bother me at all. So changing the limits of integration just means that you, remember how I told you you had to leave this blank if you had a u substitution? We're actually going to fill that in now. So u is equal to x to the 4th plus 9, and du is equal to 4x to the 3rd. I don't have a 4, so I'm going to put a 4 in the problem and a 1/4, which means now I can rewrite this as 1/4 the integral of du, the 4x cubed dx is my du, all over u to the 1/2, which of course isn't helpful. So I'm going to switch it to u to the negative 1/2 du. Changing the limits of integration simply means that I'm going to take what used to be x. So when x is equal to negative 1, I'm actually going to figure out what it is as u. So this can have its own little limits too. So when x is equal to negative 1, u is x to the 4th plus 9. So u is negative 1 to the 4th plus 9. U is equal to 10. So right there, now that we've joined the problems in terms of u, this is a 10. And on the top one, when x is equal to 0, 0 to the 4th plus 9 is equal to 9. I know you're wondering, why would you do that? I'm going to show you. So let's go ahead and do this integral. The 1/4 is a constant. The u to the 1/2, when you add 1, you get positive 1/2 divided by a half, which is not easy, so we're going to flip and multiply. And that gives me 1/2, the 2 and the 4 cancel to 1/2, square root of u. Now, because I came up with new limits of integration, I actually can stop here and use my new limits of integration with my u. I don't have to convert it back to an x. Some people really like this. They're like, now I can do this. 1/2 the square root of 9 minus 1/2 the square root of 10. There was no plugging it back into this u format. You can just work directly with u. So that is 3/2 minus the square root of 10 over 2. We're going to do 4 more. So if you didn't quite get it yet, not to worry. So u is equal to x squared plus 1. du is equal to 2x dx. I don't have a 2x dx. I have a 4x dx. So the simplest way to approach this is to add a 2 and to add a 1/2. If you're very clever and you can just break the 4 down and do a 2 on the outside and a 2x there, that's great also. They both work. So now I have 1/2 in the integral. So this 4 is, I'm going to bring it to the outside. So I have my 4, my 1/2, but my x, my dx, and my 2 made my du. And I'm going to convert this to a fractional exponent. I'm going to go one more step and change it to u to the negative 1/2 du. So this horrible number here, the negative square root of 3, all you have to do is plug that in to figure out what u would be at that point. You want limits of integration that have to do with u. So when x is equal to negative root 3, u is equal to negative root 3 squared plus 1. Well, negative root 3 squared is just 3 plus 1 is 4. When when x is equal to positive square root of 3, u is equal to the positive square root of 3 squared plus 1, which is also 4. So one of the reasons why some people like this is because at this point, you could actually tell me the answer without doing any more work at all. Think about it for a second. Do you know what the answer is? Without even integrating? The answer is 0. And that's because if you did do all the work and then you plugged a 4 in, and then you plugged a 4 in again and subtracted your two answers, they would just cancel each other out. So why do all that work? And sometimes when you take the time to change the limits of integration and do it that way, you can have nice little surprises like that. So I'm not going to finish it, because if I were to do this integral and then plug in 4 and do this integral and plug in 4 again, right? F of 4 minus whatever, I'm writing f as a placeholder, I'm definitely going to get 0. Number 3. So u is equal to 1 minus cosine of 3x. du is equal to, so the derivative of cosine is negative sign, but since it's negative, it's going to become positive sign. The angle stays the same, but then you have to do the derivative of the angle. So just to rewrite it a little neater, 3 sine of 3x dx, which of course I don't have the 3, so I have to add the 1/3. This is going to give me 1/3 u du. Very easy integral. Let's change our limits of integration. So I have this little thing that says u is 1 minus cosine of 3x. When x is pi 6, what is u? So when x is equal to pi 6, what is u? 1 minus cosine of 3 times pi 6. Remember that when you're trying to multiply a fraction times a whole number, sometimes it's easiest to give it a denominator. So you can say numerator times numerator, and then denominator times denominator. So this is actually just cosine of pi halves. Memorize it if you're in AP. You can look at your chart if you're in honors, but cosine of pi halves is 0. So u is equal to 1. I do have to say 1 is going to be a lovely number to work with when we finish. When you plug in the pi thirds, u is 1 minus cosine of 3 times pi thirds, which is just 1 minus cosine of pi. Cosine of pi is negative 1, so this becomes 1 plus 1, which is 2. So when x is pi thirds, cosine is 2, or u is 2. You literally never have to go back to this original. This new equation is the same as the old one, but much easier to work with. The 1/3 is a constant, so it stays. The integral of u is just u squared over 2. I can simplify that a little bit by doing numerator times numerator and denominator times denominator. I add my bar, and I don't need to go back to the original since I found new limits of integration. 2 squared is 4, and 1 squared is 1. That gives me 3/6 for a final answer of 1/2. Do you like it? Some people like it, and other people don't care. You will have to know how to do this for AP, though. And if you're wondering what I mean by that, they'll give you a new expression like this as a multiple choice answer. They actually don't finish the problem. They don't care about the rest of the problem. They just are testing whether or not you can change the limits of integration with a much harder problem. So make sure you're understanding all of these. Again, the answers are on that first screen if you would like to check those answers, but I am going to do the last two. U is equal to x squared minus 4, and du is equal to 2x dx. I don't have a 2x dx, so I'm going to add a 2 and a 1/2. I'm going to change this to 1/2. The integral of 2x dx is just du over, and the whole thing is u. Now, it's been a little while since we've done this. Do you remember the integral of du over u? This is a special one. I actually had a student ask me this when they were in college. They said, I couldn't figure out how to do it. I brought it to the top, and then I tried to add 1, and I got 0, but then I had to divide by 0. So that's your big clue. When you try to do this one and you have to divide by 0, that needs to send a signal to your brain that says natural log. 1/2 the natural log of the absolute value of u. Okay. All right. So I need new limits of integration. So let's do the 0 first. U is always x. So this is what x is. We want to change it to what u is. So 0 squared minus 4, negative 4. For this one, u is 1 squared minus 4. Where am I getting that from here? U is x squared minus 4. So negative 3. Those are my new limits of integration, so that's what the bar is going to go on. And I don't need to switch it back to the x's since I have new limits of integration. 1/2 natural log of 3 minus 1/2 natural log of 4, because the absolute value of u. So it's just 4. Now, for people in AP, you might have seen that I wrote the answer as 1/2 ln of 3 minus ln of 2. So this is a common thing for a multiple choice exam. In honors, you're going to have a multiple choice exam at the end of the year also. So you'll need to be able to look at something and say, is my answer the same? And the reason that it is the same is because this one is already the same. Because this can be rewritten as natural log of 2 squared. And you may remember that when you have an exponent with a natural log, you can move that to the front. So then the 2 over 2 cancel, and you just get natural log of 2. It's also possible, so this answer is good, but it's the same as this answer. It's also possible somebody takes out the natural log, and then they have, or the 1/2, and then they have the natural log of 3 minus the natural log of 4. So since it's subtraction, they might switch it to the natural log of 3/4. Also a good answer. And it's going to be your job on a multiple choice test to recognize that all of these are considered valid answers. But by contrast, I will accept any of these answers. So if you're getting to write your own answers, you can write whichever one you want. You just need to know how to convert to check your homework if the answers are written differently in the back of the worksheet, or if you're taking a multiple choice test. Last one for the day. I'm going to make my u the more complicated one normally when I have two trig functions, but you might actually just recognize that the derivative of tangent is secant squared. We'll do it both ways, but a lot of people will recognize that the derivative of tangent is secant squared, and then this just becomes u du. So when u is 0, tangent of 0 is 0. And when u is pi thirds, tangent of pi thirds is the square root of 3. When I integrate, I get u squared over 2 from 0 to square root of 3. That gives me the square root of 3 squared over 2 minus 0 over 2, which is just 3/2. If you would like to stop your video for the day, you can. But I will quick show you for somebody that said, oh, but you always say when there's two trig functions, make u the more complicated one without the actual square, though. That would have worked. Du would have been, the derivative of secant is secant x tangent of x. And so what would have happened is you still would have needed to have it be u du, because even though it's u squared, you need one of those two secants to make your du. So it ends up just being u du, which is what we had up here. But then the question is, does the rest of it still work? It absolutely does. So what is secant of 0? So remember that it's so much harder. Might be easier to make it 1 over cosine instead of secant. I was about to draw it for you. So secant looks like this. So when secant is 0, or when x is 0, secant of 0 is 1. It's right there. Remember, secant is the up and down part of this graph. But then the other one is a little bit harder. So cosine of pi thirds, so when x is equal to pi thirds, we would have 1 over cosine of pi thirds, which is 1 over 1/2, which is 2. And you might be thinking, that is not going to come out the same. They have different limits of integration, but the exact same problem. It works. U squared over 2 from 1 to 2 is 4 over 2 minus 1 over 2, which is equal to 3/2. And that's what makes math cool. Okay, different ways to do a hard problem, and either way you get the same awesome answer. All right, you did it. That is the end of definite integrals. Have a great day.